Hi, welcome to my video on odd functions. Previous video was on even functions, and this one is going to be on odd functions. So let's define an odd function. A function such that is reflected in the origin, is symmetrical to the origin, and again the origin is the point 0, 0. Or we have x comma y is going to negative x comma negative y. And notice when you have x, y, both of them are negative, so it's going across the origin. Or we could have the f of negative x is equal to the negative f of x. And this is the definition I'm going to use in this video. So the f of x equals x cubed is an odd function. Let's explain. So let's use the numbers negative 2, negative 1, 0, 1, 2. And when we cube it, negative 2 cubed is negative 8. Is negative 2 times negative 2 times negative 2. Negative 1 cubed is negative 1. When you take a negative number and cube it, you will get a negative number. 0 cubed is 0. 1 cubed is 1. 2 cubed is 2 times 2 times 2 is 8. So let's graph that. We have negative 2 gives us 8, so that's right there. Or sorry, negative 2 gives me negative 8. Got to be careful. Negative 2 gives me negative 8. Negative 1 gives me negative 1. Negative 1 for x, y is negative 1. 0, 0. X and y intercept are the same. 1, 1. X is 1, y is 1. When x is 2, y is 8. X is 2, y is 8. So this graph, we've seen this on the cubic graph before. So the graph comes down like this. And again, this is just a rough sketch. And does this. We've seen this in the unit on polynomials. X cubed. And notice that it says that this is an odd function. And if an odd function, notice that this point here is 1, 1. This point, the x is, this is positive 1, so the x is negative 1. The y is positive 1, so the y is negative 1. So the coordinates are switched to the opposite of what you have when they're odd. Another way we're going to explain this is that the f of negative x is equal to the negative f of x. So if we can prove this about any function, then we say it's odd. So the function we had, this is y equals x cubed. I forgot to put that in at the beginning because the f of x is a y. So our function is the f of x equals x cubed. So the f of negative x is equal to negative x all cubed. And the negative cubed is negative. X cubed is x cubed. And so we have, that's x cubed. So we have x cubed is the f of x. So the x cubed is the f of x. So if the f of negative x is equal to the negative of f of x, then it's odd. Why is it odd? Because the f of negative x is equal to the negative f of x. Remember, when it's even, the f of negative x is equal to the f of x. Odd, we have a negative here. So it's an odd function. So that's an illustration. So let's do some more examples. Show that each is an odd function. So the f of x equals x, that's a linear. And so the f of negative x is equal to, so we put a negative x in the place of x, done. So that's the negative of x. So x is the f of x, so that's the negative of the f of x. Very simple. So it's odd. Why is it odd? Because, again, for all these, the f of negative x is equal to the negative f of x. So if I can prove that, then it's an odd function. Let's do number 2. Again, we got to put a negative x in the place of x. Negative x in the place of x. So I put a negative x in the place of x, and negative x all cubed is negative x cubed. And 2 times negative x is negative 2x. Notice that we have a a negative common factor, so take the negative out, and I get x cubed plus 2x. And so we have x cubed plus 2x. X cubed plus 2x is the f of x. So that's the negative f of x. So again, why is it odd? Because the f of negative x is equal to the negative f of x. And let's do another one, number 3. The f of negative x. So there's x, let's put a negative x. And we have the absolute value of negative x. So negative x is okay. The absolute value of negative x is the same as the absolute value of x. And notice that's negative. So that's the negative of, and I put this in brackets, x all over absolute value of x. And so x over the absolute value of x is right here. That's the f of x. So that's the negative f of x. So it's odd. Why? And I keep repeating, the f of negative x is equal to the negative f of x. And we have another one to do. Again, we got to put a negative x in. So the f of negative x, there, 2 negative x to the 5th power. We have negative x squared. So I put a negative x right here and here. And that becomes 2. And a negative x to the 5th power is negative x to the 5. Negative x squared is the same as x squared. So that's negative 2x to the 5th all over x squared plus 1. And again, that's the negative of, and I'll put this in brackets, that's 2x to the 5. And this is x squared plus 1. This is negative, so I took the negative out. And so 2x to the 5 divided by x squared plus 1 is right here. So that's negative of, this is f of x, this is negative. So it's, again, it's odd. Why? Because the f of negative x is equal to the negative f of x. So notice we do the algebra on this to prove it. So there's a bit of algebra work. Okay, we have another question to do. Which one is or are odd functions? So we have 3 here. So let's, again, put negative x in the place of x into this question. So negative x is in the place of x. Simplify it. We get negative x to 5th power. It's an odd power, so it's negative. And that's x to the 5. And so negative 4. Negative x cubed is an odd power, so it's a negative of x cubed. So that's negative 3x to the 5 plus 4x cubed. And we have a positive here, so let's take the negative out. So the negative outside of 3x to the 5. When we take a negative out, that makes that a negative. Removing a negative, dividing by negative 1 here, that becomes positive and that becomes negative. And notice 3x to the 5 is here, minus 4x cubed, so that's the f of x. So it's odd. Why is it odd? Again, repeat, the f of negative x is equal to the negative f of x, so it's an odd function. Now we have another one to do. So again, let's put negative x in the place of x. Done. So that's a 1. Negative x to the 7th power is odd, so it's a negative, and it's x to the 7. So that's negative 1 over x to the 7, because the negative goes to the numerator. And if we take the negative, this right here we have a plus, so let's remove this negative. So there's the negative outside of 1 over x to the 7. Taking the negative out makes this a plus 2. And so 1 over x to the 7 is here. That's a minus 2, and that's a plus 2, so it's not odd. It's not odd. So we got to decide if it's an odd function, but it's not odd. And notice if this was, we got a negative here, so it's either an odd function or not odd. If this was a positive, then we have a choice to say it's odd or even. Okay, here we go with this one. Is it odd or even? And we have let's see, this is odd. Okay, sorry about that, I just had a thinking. The f of negative x is equal to negative x all over the absolute value of negative x. So that's negative x. The absolute value of negative x is the same as the absolute value of x. So that's a negative of x all over absolute value of x. And so that's f of x. So it's odd because the f of negative x is equal to the negative f of x. So we have explaining what an odd function is. Again, repeat, if the f of negative x is equal to negative f of x, if we can show that, then it's an odd function. And that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.